All right. So the question that we're talking about in hypothesis testing is, how are we going to make some decisions? Consider this idea. Do students at Western own cats more than the national proportion? So we're talking about how many cats do people normally own. And surveys out there say about 30%. And so I want to know, what about students at Western? Do they own more cats than that? So then, how am I going to prove that? Well, I have a problem, okay, if I'm going to try to prove that, because I know that samples are not accurate, right? So that if I take a sample and I say, well, I did a survey and I found out that it was 40%. Well, that doesn't prove anything. It doesn't prove that it's different because it's a sample, right? Because we've talked about sampling variation. Sampling variation tells us we cannot prove anything directly by just looking at the samples. But what we can do is we can think about that sampling variation, because we know that sampling variation has a distribution, right? And we know that if our sample size is large enough, the sampling distribution is going to be bell-shaped. And so then we can control, or we can understand what might happen, because when we do samples, we can know how much variation is going to be in our samples. So then we can actually figure out what to expect from a sample. Now, the logic of hypothesis testing goes like this. If we get an unusual result, that means that then our assumption about the population may be wrong. So, I'm looking at my sample. I say, all right, I've got variation in my sample, and I can expect that, right? But if something happens which is unusual, then maybe there's something going on with my assumption. Remember, when we talked about this, we assume that a population and the sample distribution have the same mean, okay? But if we get some kind of an unusual result, it's like, well, wait a minute, that may not be right. Let me give you an example here. Consider that this idea, do students own cats more than national proportion? The national proportion is about 30%. So if I say that the national proportion is 30%, and yet I get a sample which is out here at 40%, then I look at that and I say, well, wait a minute. If there's a large, significant difference here between these, then that means the meaning of that measurement, it could be that what I'm measuring is not actually from that population. That with Western students, when I took that sample, they don't have a proportion of 30% cat ownership. And so that is why my sample was so high at 40%. So what I'm looking for is unusual results, which will then tell me that where I got my sample is not the same as the assumption that I had made. Okay, I'll come back to that in just a minute. But that is the basics of hypothesis testing.